So why are we so enthusiastic about this project? Well, let me draw your attention to the title, the full title behind the SofTMech acronym. This is an EPSRC Centre for Multiscale Soft Tissue Mechanics. So at its heart lies a serious mathematical challenge to develop a framework for soft tissue mechanics that goes from the subcellular to the cellular to the multicellular to the tissue and indeed to the organ scales. Now that in itself is a really exciting project.
What are the aims and the objectives? Well, in the first instance, we're going to be concerned with the mathematical modeling of soft tissue mechanics, or more strictly biomechanics. You can't do the modeling without data. We need a lot of data from experiments on soft tissues of various types, and we have associated with the project 8 or 9 different labs which will be able to provide that sort of data in the form that we need it. We're fortunate to have within our team a number of world-leading scientists, and we hope to build on that by ensuring that the centre actually becomes recognized as a world-leading centre for mathematical sciences in healthcare.
As you know, I'm not a mathematician, I'm not a biomedical engineer, so the expertise lies with you, so what I say is to some extent redundant, but I just wanted to emphasize how important a centre like this centre is going to be to the life of the university over the next few years. Now, EPSRC has chosen to recognise and invest in what you all collectively have to offer, working in partnership not only across this university, but as Adrian said, also with our partners, the universities of St Andrews, Heriot-Watt and Sheffield, and it is a great team given the expertise across these partners. And I do also want to, like Adrian, echo the thanks to EPSRC for their support and commitment to this project.
EPSRC commissioned a review by Sir Patrick Maxwell in 2012 to kind of understand the development of APS research into this space. Without mathematical, statistic, physical sciences, engineering and computer science research, we really wouldn't have got to the stage that we are currently, and we really wouldn't have kind of broken ground in the elements that we have. And it's really important for us to continue pushing this research so that we can create applications in this space.
So I want to focus on 2 aspects. First on arteries and then on the myocardium. I recognize that the arteries are not really the focus of the center, but I think there are a lot of ideas inside what you can directly transfer to the heart.
We have very ambitious plan for how to carry multi-scale soft tissue mechanics, but that is really ambitious. You all know there's a lot of challenges and the extremely difficult target. And so we cannot do it on our own. We have about 14 members of academic staff supported by 5 RAs and 8 PhD students. We also have a lot of collaborations with companies such as Abacus from Dassault Systems and ANSYS and Siemens as imaging company, and also Insignia and other centers. And so we hope to engage with everybody who are interested in this area to do this great work together.
So Xiangyu gave a ground idea about SofTMech, and which is, from the fundamental to the whole body. And I was very excited about that. And my research focus on basic unit of life cells, and I think that the engineer can contribute to this ground challenge. And obviously that health problem is complicated and it requires all the scientists and engineers work together to find the solutions.
I would like to tell you a little bit what we're trying to do in Sheffield at the Insignia Institute for In Silico Medicine, and how I hope this might be an opportunity to collaborate much closer with the new center here in Glasgow. So first of all, what do we mean for in silico medicine? Well, I suppose you can give quite a few definitions. For example, you can define it by process. So it means to develop predictive models which are informed by data collected on individual patients and by mechanistic knowledge models that are then captured into systems that can be deployed in hospitals, so to be used by medical professionals as support to their decisions, which imply that, of course, we need to assess them in terms also of clinical accuracy, not only of engineering accuracy.
So I want to come to the end. This is my last slide about the current members of the group. I want to emphasize here the collaborations, in particular with the University of Glasgow. I have here mentioned 3 names. This is Ray Ogden, Shaul Yu, and also Nick Hill. And I really wish you, all 3 of us, because you are really driving the whole vehicle, all the very best for the next 4 years, and hopefully for the another 4 years. Because as we just learned, this is a good start now, but there might be a possibility to get even more money, or to bring even more money in. So I'm very happy that an official visiting professor here at the School of Mathematics and Statistics, and I do all my best to help out in any aspects what I can do for the future. So thank you very much for your attention.